Today's lesson is on partial linear relations. So the ones we had talked about so far are linear relations that are straight lines. They have positive slopes, and they all included the order pair 0, 0. They are called direct linear relations. But sometimes variables do not have all these three qualities. When a linear relation does not pass through the origin, it's called a partial linear relation. So there's an activity that is attached that you should work through. You're going to create a table of values for Joseph. He is renting a moving van, and he needs to rent a van for $20.95 plus 69 cents per kilometer. So you're going to create a table of values, figure out if it's a linear relation or not. Does the graph pass through the origin? And there's a second scenario with Francesca. Okay, so you're going to see on the next slide the answers to this. So a table of values, well, if you don't go any distance, then you still cost you to rent the van $20.95. And then if you drive 10 kilometers, the price goes up because you have to add in the cost of the kilometers. Okay, you're going to graph it. You'll notice the graph does not start at 0, 0. It actually is at 0. This point is 0, 20. So when you haven't driven any kilometers, you're still paying $20. Okay, the graph is linear, but the graph does not pass through the origin. In the second example, because you are paying off a loan, the amount of money you owe is still going down. So your linear relation is actually negative. And it starts at 0 to 100. That's how much money you owe. And then you're paying it down to eventually 11 days you have no money. Okay, so we're going to do an example together. Anja is an events coordinator at a banquet hall. She arranges weddings for receptions for clients. She has not yet decided on the number of guests, so they ask Anya what price would be between 50 to 200 people. So she creates a table to show the prices. Okay, so if nobody comes, then you still have to pay the rental hall. If 50 people come, it's $2,000. If 100 people come, it's $3,500. Is the relation between the number of guests and the cost linear? Well, yes, it is. The relation is linear. How do we know that? The graph is a straight line. And the slope is constant. So it doesn't matter which 2 points I pick on this graph. I could pick these two and calculate the slope, or I could pick these two and calculate the slope. The slope would be the same. So the slope is constant. Does the line pass through 0, 0? Well, no, it doesn't. It actually intersects the y, intercepts the y-axis at 500. What that means is the base price is $500 for the reception. So it doesn't matter how many people come, you're going to pay a minimum of $500, and then the price increase with the number of guests you have coming. What is the slope of the line, and what rate of change does it represent? Well, we're going to pick a couple of the points. We're going to pick this one here, so 0, 500, and we're going to pick the second one up, which is 50, 200. Now we're going to use our slope point formula to calculate the slope. So we take this should be 2,000. 2,000 minus 500, 50 minus 0. 1,500 over 50, so your slope is equal to 30. What that means, if you look, the slope is the rise over the run. The rise is cost, the run is number of guests. So your slope is 30 cost dollars per number of people per person. Okay, so the slope tells you how much you charge per person, and the base price is $500. Okay, so there's the full answer. Okay, classify the following graphs according to the following criteria. So is the graph linear or nonlinear? Linear means it's a straight line. Nonlinear means it's curved or it's broken up and it's not totally straight. Is the dependent variable increasing or decreasing as the dependent variable increases? So is your line going up or is it going down? Okay, this one is linear. It's a straight line. The second graph is nonlinear. You'll notice it curves. The third one is also nonlinear. Goes up as a straight line, and then it breaks off, then it goes down, then it goes up. Okay, it has to be consistently straight. This one is going downhill. Okay, so it's decreasing. This one is also decreasing. And this one is a variety. Here, it's increasing, and it's increasing here, and then it's decreasing here. Do you agree or disagree with the statement graph 3 passes through the origin and is therefore a direct linear relation? Well, yes, graph 3 does pass through the origin, but it is not a linear relation. So it is not a linear relation, so it's not direct. Okay? All right, you're going to work on Build Your Skills, page 18, 19, as well as page 26 and 27. After you've completed those questions and corrected them, you're going to move on to the Practice Your Skills, which is the end of the section questions, page 28 to 31. 3 additional questions follow this slide. So number 3, there's a graph. Number 7, a graph and the answer. And number 8, the graph.